Solid waste or municipal solid waste. What do you mean by a municipal solid waste? Municipal solid waste are generally those uh, things which we throw away or those trashes which are discarded in the public. It can be paper, plastic, food waste, ash, liquid waste like paints, medicines, oils, timber, plastic, any such things which are discarded in the public. So, what are the sources of municipal solid waste and what are the classification of municipal solid waste? The municipal solid waste generally have the following classification: garbage, rubbish, ashes, street refuse, dead animals, abandoned vehicles, industrial waste, demolition waste, construction waste, special waste, sewage treatment residue, etc. These are all the classification of municipal solid waste. So where do they come from, and what are they composed of? So generally, those materials or things which are coming out from a household, a restaurant, any institution, stores, markets, etc., would fall under the classification of garbages, rubbish, ashes, etc. Uh, what is this garbage consist of? This garbage means those waste which are produced from households while cooking, while serving food, those vegetables or other things which comes out from market as waste, uh, some waste from handling storage and those things which are for sale as products are called as garbage. Uh, what do you mean by rubbish? Rubbish are actually those combustible and non-combustible materials. Combustible materials like paper, cartons, boxes, barrels, wood, tree branches, yard trimmings, wood furniture, bedding, etc. Those stuffs which are combustible. Also, those non-combustible materials like metals, tins, cans, furniture, the other furniture which are not made of wood, dirt, glass, crockery items, minerals, etc. Would consist the classification consist are included in the classification of rubbish solid waste. So as I told, they can be combustible or non-combustible. Then there will be those remains after combustion, which we call as ashes. Then also all these the garbage, rubbish, ashes, all those stuffs would come from any household, restaurants, institutions, stores, or markets. Then the next category, which we can call as street refuse, dead animals, abandoned vehicles, etc., which comes from streets, sidewalks, vacant lots, etc. The street refuses may include sweepings, dirt, leaves, basin dirts, uh, then like any sort of litter receptacles. Those can be categorized as street refuse. Then there can be we all see this dead animals on the road. That can also be a solid waste like cats, dogs, squirrels, deer, anything hit by a vehicle or any by dead by any other means which we may come across in some open lots or streets or roads. Then there will be abandoned vehicles, which can be classified as municipal solid waste again. The industrial waste, which come from factories or power plants, like food processing waste, boiler, lumber, scraps, metal scraps, shavings, etc., would get categorized under industrial waste, industrial solid waste. Then there will be there's demolition waste and construction waste. The demolition waste, once we demolish this unused or any illegal buildings and all, there will be a lot of concrete blocks or pipes. There will be bricks, masonry, other types of masonry, other types of structures that may get disposed of as solid waste after the demolition of buildings. The same applies in the case of any construction industry or even in the new constructions. There may be chances that many scrap materials, scrap lumber, scrap pipes, scrap reinforcements, scrap bricks, etc., are left out after the construction. So all this forms solid waste again. Then there will be some other waste like hospital waste, and then other types of explosives which form part of any type of operations. Then other sort of hazardous waste. This hazardous waste, explosives, pathological waste, other radioactive materials and other types of waste would get into the category of special waste. Then there will be this sewage treatment residue, like solids from core screening and from grid chambers, septic tank sludge, and all. All these are those steps which forms the classification of municipal solid waste. Now we need to get into the topics which cover the physical, chemical, and biological characteristics of the municipal solid waste. So, the three basic characteristics that we need to know about the solid waste are their physical, chemical, and biological characteristics or their properties. So, why do you need to know about this physical, chemical, and biological characteristics or properties of municipal solid waste or simply the solid waste? It is because once when any material is turned out to be a waste, there are many ways it can be converted. Like this waste can be reused, whether there is a scope of reuse from this waste, whether we need to incinerate them, whether we need to dispose them in a landfill. All these stuffs needed to be decided on the basis of all this chemical, physical, or biological characteristics of each of those. So that is why understanding these properties are important. So first of all, we are gonna see what are the physical characteristics of municipal solid waste. Uh, the major physical characteristics that we need to know is one, density or the specific waste of solid waste. Then there is moisture content, particle size distribution, the field capacity, hydraulic conductivity or permeability, uh, or the shear strength of the waste. So all these are those main physical characteristics that we need to study. First of all, density or specific weight of a municipal solid waste. The specific weight or density is the weight of a material per unit volume. It actually varies for different types of municipal solid waste. We have already discussed there are many types of municipal solid waste, like there can be paper, there can be cardboards, there can be metals. So the municipal solid waste as a whole won't have a specific weight or a density, but it ranges between 200 to 400 kg per meter cube when we are talking about compacted the solid waste. The term compacted solid waste comes from by assuming that the solid waste would end up in landfill, and once these stuffs are compacted in a landfill, what would be the density of the solid waste mixture generally? That's what we are discussing here. So it generally comes around 200 to 400 kilogram per meter cube. Um, Again, this another type or another physical property that we need to address is the moisture content. It is again, as I have already mentioned, you need to know about the fate of the waste of the solid waste. Is this waste suitable for composting? Is this waste going to get incinerated? Are they going to end up in landfill? So this municipal solid waste, I mean, the moisture content of the municipal solid waste is actually important in deciding what is the fate of the waste. It depends on the moisture content in municipal solid waste depends upon many factors, like what are the composition of the waste, which season of the year is it. In a rainy season, obviously the moisture content will be large. In dry seasons, the moisture content will be low. Then whether the area, the particular area, the particular region from where the municipal solid waste are being generated, or is being under consideration, has a higher temperature or not, what is the state of humidity in that region, what is the weather, etc. All these stuffs would decide what is the moisture content of the municipal solid waste that is coming up from that particular area. Generally, those waste which end up in landfill in their compacted form will have a moisture content of 15 to 40 percentage. Again, all these the moisture content would also depend upon the calorific value, what is the landfill sizing, what is the reactor sizing, etc. Now, what is the particle size distribution of the municipal solid waste? Particle size distribution means what is the average size of the particles of the municipal solid waste mixture. So that is important in deciding whether you need to do incineration, or the components of this municipal solid waste get are they going to get biologically transformed or not. So if we have to go for a biological transformation method, you need to know about the particle size distribution of the solid waste material, solid waste particles. Whether you have to recycle it, whether you have to reuse it, all these decisions would depend upon the particle size distribution. It is important in the case of material recovery from the solid waste, for composting, incineration, landfilling, whatever. So it affects the again, this particle size distribution also affects the porosity and permeability of the waste in the landfill, which would be very important in the design of the landfill also. Then talking about the material recovery, if you need to separate out the different solid waste mixture, what mechanical means do you need to resort to would depend upon the particle size distribution. Whether you need to use a trommel screen, whether you need to go for a magnetic separator. For all these decisions, you need to understand what is the particle size distribution. Basically, as a thumb rule, you can say that the average size of a municipal solid waste mixture, average particle size should would be generally around 100 mm. Now, the next important physical property of municipal solid waste is the field capacity. What do you mean by field capacity? It is a total amount of moisture that can be retained in a waste sample subjected to gravity. So that is very important in the landfill design especially. It is important in determining the formation of leachate in the landfill. Leachate is actually the water, the excess water, or the water in excess of field capacity which will be released from a solid waste. So this leachate design is very important, and or understanding about leachate is really important in the case of the design of a landfill. Remember, the field capacity is the total amount of moisture that can be retained in a waste sample. But it depends upon many other factors also, especially for those ways which would end up in a landfill. The field capacity would depend upon what is the applied pressure on the landfill, how well or how much pressure is applied to compact those solid waste in a landfill, and what is the decomposing capacity of the components of the solid waste in that particular landfill. Generally, 50 to 60 percentage of uncompacted residential generally the uncompacted residential and commercial waste will have a field capacity of 50 to 60 percentage. The next is permeability of the compacted solid waste, or it can also be called as hydraulic conductivity. It governs the movement of liquids and gases in a landfill. It depends upon the particle size distribution, depends upon surface area, and it depends upon porosity. Usually, for an uncompacted solid waste, the typical value of hydraulic conductivity would be like 10 raised to minus 5 meter per second. If it is compacted solid waste mixture, then the vertical hydraulic conductivity would be in the range of 10 raised to minus 12 to 10 raised to minus 10 raised to minus 11 to 10 raised to minus 12 meter per second, and the horizontal hydraulic conductivity would be in the range of 10 raised to minus 10 meter per second. Another physical property which is very important in the design of landfill and all is the shear strength of the solid waste. The better the shear strength, the better will be its capacity to, or in a better way we would be able to stack up the solid waste in a landfill. So usually the sludges and all, those liquid or semi solid material that form out of solid waste, the sludge will have zero shear strength. But when this sludges and all get mixed with the other dry refuses like papers, cardboards, or the metals and all, the shear strength improves. In the landfill, the shear strength is highest when, just if we are talking about, if we consider the fate of the solid waste is to end up in a landfill, usually, and if we are talking about a scientific landfill, then the shear strength of the solid waste will be highest in the landfill when it is just after the compaction. Just after the compaction, it will have its highest shear strength, but with time, it will lose its shear strength. And we already know that many cases, even in Delhi and all, there has been this landslides in this such landfills, which has already been stacked up to more than 50 or 60 meters height from the ground level. So this landslides and all in this landfill happens, and the accidents occur due to the lack of shear strength in the landfill. Of course, when you say that example, the landfills the landfills which we are talking about in Delhi and all are not those scientific landfills. Again, the shear strength would also play a role in the case of a even in the case of a scientific landfill, because it depends on what is the shear strength, or what shear strength can a solid waste mix can gain once it is compacted in a scientific landfill. It would depend upon what is the fate of that particular area once the capacity of the landfill has been met, whether you will be able to do any sort of recreational activities once the capacity is met. All those steps would depend upon the shear strength of the solid waste in a landfill. Now that we are done with the physical characteristics, let us move on to the chemical characteristics of the municipal solid waste. Uh, why do you need to know about the chemical characteristics? For example, again, as I had told about in general before starting to discuss about this property of solid waste, let's say for whether you need to to burn a solid waste, what is the feasibility of combustion? You need to know about the chemical characteristic. So there are whether you need to yeah, whether you are gonna reuse it when you whether you are gonna recycle solid waste mixture, all these stuff, or even in the design of a landfill, what are the different types of gases that may be generated out of a landfill, whether you're gonna use those gas developed from the landfill for any other purposes. You need to know about the chemical characteristics. So what are the ways in which you can actually analyze the chemical characteristics? There are two or three methods by which it can be done. One is proximate analysis. This proximate analysis is particularly done to determine the water content, to determine the volatile combustion matter, to determine the fixed carbon, to determine the ash content, etc. Um, Water content. When you talk about water content, you'll be analyzing what will be the loss of moisture when it is heated to 105 degrees centigrade. You do that by proximity analysis. Similarly, when you talk about this volatile combustion matter, the analysis is about understanding what is the loss of weight on ignition of the dried sample of waste would have at some 950 degree centigrade in a covered crucible. So, what is the loss of weight the waste is going to have when it is ignited at some 950 degrees centigrade? By that analysis you can understand whether what percentage of volatile combustion matter is included in the solid waste mixture. Fixed carbon, what do you mean by fixed carbon? It is like what is the combustible residue that is left after the volatile matter is removed from the waste? Once the volatile matter is removed from the waste, what is the combustible residue that is left with? So that is what is called as fixed carbon, and you understand that with the help of proximity analysis. Then talking about ash content, what is the weight of residue of waste after the combustion in an open crucible? What is the ash which is left after this waste is combusted? That would give you an idea about the ash content. So again, all these stuffs, you come to know about the water content, you come to know about the volatile combustion matter, the fixed carbon, the ash content, all by the proximity analysis. What do you mean by ultimate analysis? Ultimate analysis of solid, it is mainly used to determine the percentage of carbon, the percentage of hydrogen, oxygen, nitrogen, sulfur, ash, or halogen, etc. It is a chemical composition. The chemical composition of the organic matter in the solid waste. It is important. For example, why do you need to know this? Why do you need to know about the percentage of carbon that is present? Why do you need to know about the percentage of nitrogen that is present in the solid waste mixture? It is important to. I'm going to give you an example. Like, why do you need to note all this stuff? For example, this carbon nitrogen ratio. What is it is important to know about this carbon to nitrogen ratio of a solid waste mixture. If we have to compost a solid waste, you should know the proper mix and all. Because it controls the biological conversion activity of the waste. So only if you know this carbon to nitrogen ratio, you can decide upon whether how good it would be when it is when we are gonna compost it, when we are gonna burn the solid waste. So all these stuff matter. So determination of carbon, hydrogen, oxygen, nitrogen, etc. can be done by the ultimate analysis. So we have talked about the proximity analysis. We have talked about the ultimate analysis. Uh, the next property that you need to know about the municipal solid waste is the biological properties. Mainly, when you talk about this biological property, you'll be checking whether the solid waste is biodegradable or not. Um, Whether all the organic compounds are degraded and converted into biologically converted into carbon, hydrogen, like carbon dioxide, water, methane, etc., or any other simple compounds, either aerobically or anaerobically. So in short, you need to check whether you need to understand whether the municipal solid waste in your hand is biodegradable or not. That is really important. You need to know about whether what are the whether there is a chance that a foul smell is produced when you dispose this municipal solid waste in a landfill. Whether any types of as I have mentioned earlier while talking about the chemical composition, whether some sort of gases is gonna erupt out of this waste from the landfill. Is it going to breed some flies and maybe end up in some develop some sort of diseases which is spread by the flies which breed from this municipal solid waste which is disposed in a landfill. All this is very important. So if the material, if the solid waste mixture is going to get biologically degraded, how fast is it going to get degraded? Is it going to get degraded very rapidly, or will it be very slow? You need to know about this biodegradability of this waste. So to understand the biodegradability, you can indicate the biodegradability of a municipal solid waste mixture using a factor which is called as biodegradable fraction. It is called as BF, the biodegradable fraction. So different types of municipal solid waste would be having a different biodegradable fraction, which is represented obviously by a number. It will be like decimal, like 0.4, 0.5, 0.8, like that. So the higher the biodegradable fraction, the higher will be the biodegradability. Some materials like food waste, yard waste, office papers, etc., some of the examples of municipal solid waste with high biodegradable fraction, so that we can understand from the high biodegradable fraction that these materials or the stuffs would be highly biodegradable. Whereas there are some other ways like newsprint, like cardboards, etc. Those are some of the examples of municipal solid waste which are less biodegradable, which means those stuffs will be having a low biodegradable fraction. So these are the main points which we need to cover when we talk about the physical, biological, and chemical characteristics of municipal solid waste. So in this episode, we have discussed what is this municipal solid waste, what are the sources of various municipal solid waste, what is the composition of municipal solid waste, what is the classification of municipal solid waste, and the physical, chemical, and biological characteristics of the municipal solid waste. So in the next session, we will discuss about e-waste. Okay, so let us wind up here for today.